All right, I hope everybody's staying warm today. So we have the unit 4 review. So let's look at it. So it has to do with exponents and logarithms and the exponential equation. So, and I will do maybe one other one um, with the vertex form, a couple of things we did from unit 6 that could be on the term on Wednesday. But here we go. Let's try to keep this short. So I'm going to go fast, and you could stop when you need to help and rewind it and all that stuff. All right. So for this one here, right, that means we can make this a positive exponent by taking the reciprocal of it. 4/3. Okay. That's a horrible looking exponent. It should be 4/3, right? The exponent. So we write that fractional gets put into a radical form. The numerator is the exponent of the x, and 3 means the third root. So we put it right there in the little house there. Okay. Now the next one is this is the general form of an exponential equation, right? And you have two. This one is decreasing, so A, that means that B is less than 1. That means it's decreasing. If B, if it was increasing going this way, right, this B would be greater than 1. It would be a whole number, not a fraction or a decimal. Less than 1. Okay, and then the other part is, where does it pass through the y-intercept? That's the A coordinate. So the A coordinate is greater than 0 and less than 5. Okay, so we have to look which ones have both of these conditions in it. So the first one, we're missing the B greater than 1 is not there, right? B is not greater than 1, otherwise it'd be increasing. Number 2, the y-intercept greater than 5. That's not true. It's between 0 and 5. The second one has A less than 5, but B less than 0. You can't have a negative. And then part C, part 4, it has both of our conditions, right? Less than 5 and B is less than 1. Okay, and you can take this general form of an equation, and if you're given 2 points, this one, and we're going to do one where we find the entire equation. But here they just want us to find out what B is, right? We're going to find the value of B. So you can make a system of equations, right? This is 4, 6, if you think about it as a coordinate, where 4 is x and 6 is y. And this one is 8, 0.5. Okay, now I always say to put the bigger x on top, because you'll see why in a second. So instead of using h of t, I'm just going to use y. So for this first one, right, h of t is 8, right? That's this number, is equal to a times b raised, oh, I got them backwards. No, yeah, I got them backwards. Hold on, let me erase these. Whoop. That's funny. This is 0.5 b raised to the 8th. I'm going to copy it right off my sheet so I don't screw up. There's an equal sign between them. Okay, the second equation, we're going to do it the same way. We're going to put 6 is the y, right, is equal to a times b to the 4th. Okay, now we can divide these two. So when we divide these, we have 0.5 over 6. The a's will cancel out, and then we're going to subtract the exponents. 8 minus 4, right? 8 minus 4 is 4. Okay, and then we're going to raise this to the 1/4 power, because if we multiply 4 times 1/4, the 4's will cancel out and we'll get b. So we'll have b, these two cancel, right, because it's 4/4 or 1. We also have to do it to this side of the equation, raised to the 1/4. So b will equal to 0.5 over 6 raised to the 1/4. Now you should always try to leave them to the end if you can. So now all you have to do is go to your calculator. All right, go to the calculator. Let me clear this. And we're going to do a fraction, right? 1. The numerator is, I don't know why I have a negative there. Let me clear that. Okay. Let's try again. 0, 1. Right. And this is 0.5. I'm going to clear this. I want to put it in parentheses because that's how I have it on my paper. So I'm going to open up parentheses. Now I'm going to put the fraction in. Okay, 0.5. Move this down. We're going to put in 6 here. We're going to move this over and we're going to raise it, which is the button above the divided button. Raise. And we're going to make this a fraction. So we're going to put an alpha 1 here. We get that fraction up there. And it's 0.5 divided by, whoops, I'm sorry, not 0.5. Delete, delete, delete. 1 divided by 4. 1/4. And we get point B is equal to 0.5372. So the closest one is, rounded to the nearest hundredth, is number 3. Okay? All right, let's keep going. Here we go. So these are, the easiest way to solve these is common bases. The method of common base. All right, so we have a 4. If we rewrite 1/4 as a base 4, it's raised to the negative 1 power. These two are equal to each other. And then we're going to raise that to the 2x minus 3k. Okay? And then we could rewrite 16 as 4 raised to the 2nd power. And let me just write it different. 4 raised to the 2nd power. And then this is raised to the 4x plus k. Now that we have the same bases, we can let their exponents equal, right? Equal each other, right? So we could set the exponents equal. So when we raise a power to a power, we have to multiply them. So we're going to have negative 1 times 2x minus 3k is equal to 2 times 4x plus k. Okay, we're going to use the distributive property. We're going to get negative 2x plus 3k is equal to 8x plus 2k. Okay, and now we want to solve for x, right? So we can subtract 8x from both sides because I like mine on the left. You could go the other way if you'd like. This is negative 10x plus 3k is equal to 2k. And then if we subtract 3k from both sides, we end up with negative 10x is equal to negative k. Then we divide both by 10, by negative 10, and we get x is equal to k over 10, which is choice number 1. All right. Number 5. So because it says it's a percent increase, the population, it follows the exponential formula, which is the P is equal to the initial amount 1 plus the percentage raised to the time. Okay, so we have the initial amount is 25,000 and the increase is to 36,000 over an 8-year period. If it was a decrease, we would do 1 minus P. All right, so let's fill in what we know. We have 34,000 is equal to 25,000. Okay, times 1 plus P is what we're looking for. What percentage below is the closest? Raised to the P time period, which is 8 years. Okay, so we're going to isolate this 1 plus P. We're going to divide 25,000 divided by 25,000. Okay, so 34,000 divided by 25,000, right, is equal to 1 plus P to the 8th power. Now, to get rid of this 1/8, I have to raise this to this 8, I have to raise it to the 1/8 power. And I have to raise this side to the 1/8 power. Okay? So then I'll have 1 plus P is equal to whatever this is. So how do you put that in your calculator? So we go over to the calculator, right? Split view for me. And again, I'm going to start with parentheses. I'm going to put in a fraction, alpha fraction 1, 3, 4, 0, 0, 0. And the denominator is 25,000, 25,000. Move it outside the parentheses, raise to, and now we have a fractional exponent again. So I'm going to put in another fraction. 1. And that exponent is 1 over 8. We hit enter, and we get 1.305. So this is 1.039. Okay? Now, the first part is the number. This second part is, if you subtract 1 from each side, you end up with P is equal to 0.039. Okay, but we're going to move it into a percent by multiplying by 100. So it's number 2, 3.9. All right, so which one makes this log undefined, right? So 2x minus 3 has to be greater than 0. It can't be equal to 0, and it can't be a negative number. Okay? And I'll show you that in a second. But if you solve this, you can just solve this to plus 3 plus 3. 2x is greater than 3. Divide by 2, divide by 2. I get x is greater than 3 halves, which is 1.5. So which one makes it undefined is going to be less than 1.5. And the one that's less than 1.5 is number 1. Now, you have a log base in your calculator. You can check these. You're at the exam and you're like, oh my God, but I have all this time left. You could take this if you go to math and you go down. Log base, right? I'm going to enter this one. So if I have log base 7, so I'm going to put a 7 here. Then we go inside the parentheses, and I'm going to use the first choice, right? I'm going to use 2 times 1. 2 times 1 minus 3. And I hit enter. It says not a real number, right? Yours will probably say error. So that one doesn't work. But if we try like the other ones that are bigger than that are larger than 1.5. I'm just going to do second answer, and I'm going to go back. No, sorry. Let's clear that. Second entry, which is the enter button. You can just go back and change this, right? Delete that number and say you put in 3, right? And 3 gives you an answer. So that one is okay. All right. So that's 1. All right. If the equation of 3, 5 raised to the 2x power is equal to k is solved for the x term of k, the result is, now, this 5 is the base, right? So we're going to deal with base 5. We're going to exclude that one. All right, so how do we take the base, right? Well, first thing we have to do is we have to isolate the term with the exponent, right? So we have to get 5 to the 2x by itself. So we're going to divide by 3. Divide by 3. I have 5 raised to the 2x is equal to k over 3. Okay, now we're going to take log of both sides. So the exponent goes in front. 2x log base 5 of 5. 5, right? Is equal to log base 5 of k over 3. Okay? So, when you have a base raised to itself, right? This is 5 raised to what power is 5? It's always 1. So you can always cross it out. If the base and this number are the same, you can cross it out. It's 1. So this is 2x is equal to log base 5 of k over 3, right? So all I have to do is divide both sides by 3. But where do I divide? I can't divide inside the log. There's a 1 out here. I got to divide that by 2. So my x will be equal to 1/2 log base 5 of k over 3. Okay, and one more. I think we have one more here. This is a nice one, right? It's coffee, and they want to know M represents the minutes has been cooling. How long does it take for the temperature to become 35 degrees Celsius? Okay, so if we look at this, we're going to put in 35 degrees Celsius is this. That's the temperature. So we're going to say 35 is equal to 57 e to the negative 0.11 m plus 20. Okay, so we want to isolate. This term. Okay, so we're going to subtract 20 first. I'm laughing because I did it earlier, and I got a negative, and I was wondering where the negative was. I didn't have the negative 0.11 on my script, so I'm going to make sure I put that there for you guys. All right, so this becomes 15 is equal to 57 e to the negative 0.11 m. We're going to divide by 57. Like I said, you know, you can divide it and you'll get a decimal, and then you have to carry the decimal. But it's easier, really, if you just keep this until the very end, until we get m's equal to something, and then we could put it in. All right, so this is equal to e to the negative 0.11 m. Okay, now we're going to take the natural log, and we can't take the log because we're dealing with e. I mean, it does work, but it's really not acceptable. Natural log 15 over 57 is equal to, the exponent goes in front, negative 0.11 m natural log of e. Okay, I had forgotten there's the negative there, but it's there. Remember, this is base e to the e, and I said that that's always going to be 1. So the natural log of e is 1. Right, so we could eliminate that. right? And then to get m by itself, we're going to divide by negative 0.11. Okay, so we're going to divide this by negative 0.11. Okay, so that's what m is going to be equal to, that big messy fraction. So let's go to our calculators. How do we put in big messy fractions? A little bit at a time, you know, as the old wise saying goes. All right, so I'm going to put in, I'm going to go alpha y equals 1. In the top of my fraction, I have the natural log, which is underneath the log button. I got to put in a fraction here, right? Second, y equals 1. 15 over 57. Okay, and then in the denominator, now I can scroll out till I get to the denominator, and that's negative 0.11. Okay, and if we did everything right, we get m is equal to 12.136. Okay, so the closest one is 12. Right, like I said before, I messed up. I forgot that negative, and I had a negative 12.136. I was like, oh, but it always works out at the end. All right. I think I'm going to stop this video so they're not too long and I can upload them quicker, and then I'll come back and do the part 2 questions.